Hi, we are Elme Magaña, Aniacon, and Maria Jose Vargas, and today we're presenting the topic of projectile motion with a problem that says that a cricket jumps with an initial velocity of 2.15 meters per second at 61 degrees above the horizontal. It's dropped by a bat 28 seconds after jumping. A. What are the x and y coordinates where the cricket is dropped relative to its jumping point? B. What is the speed of the cricket when the bat drops? C. What is the maximum height the cricket reaches? And D. How far could the cricket get if there had been no bat? But for a better understanding of the topic, we can divide the subject. First, knowing that a projectile is any object that once is dropped continues its motion by its own inertia but being influenced only by the downward force of gravity. So if we are talking about projectile motion or parabolic motion, we are also talking of motion in two dimensions, horizontal axis and vertical axis, with a velocity that's forming an angle with the horizontal. I mean, on x-axis, the body moves at constant velocity, but in y-axis is a constant acceleration due to gravity, as the path follows for the trajectory. But the most important fact to remember is that the motion along perpendicular axes are independent and thus can be analyzed separately due to acceleration is the same regardless of mass, like if motion in x direction does not affect motion in y direction.
For the projectile motion, we had some elements like is the initial velocity, the time of flight that is divided like into like the total time and the time of the maximum height, the acceleration that in x is equal to 0 and in y that it's the gravity that it's minus 9.8, the velocity, well, the final velocity and the displacement. We can have the for the x-axis and y-axis for where those is the maximum point, the initial point, and the final point. The maximum height that it's, well, obviously the maximum height, and also the time that it's different, that it's the half from the total time.
Problem says that a cricket jumps with an initial velocity of 2.15 meters per second with a 61 degrees in the horizontal, and it says that a bat intercepts at 0.28 seconds. With this information, we can deduce know that our initial position in x and y it is 0, and our gravity in y it is minus 9.8 meters per second squared, and in x our acceleration is going to be 0. Now, the problem gives us the initial velocity. We need to have the initial velocity of y and x. First question, it is asking you for the position of x and y when the bat intercepts. We have a formula that says that the final position it is equal to the initial velocity plus initial velocity multiplied by the time. But we have all the values except the initial velocity of x. But we can get that by multiplying cos to the degree multiplied by 2.15, and we get the initial velocity of x. And now we can substitute the values, and by doing that we get to the result that it is 0. Now we need to get the position of y. It says that it is equal to the initial position plus the initial velocity of y multiplied by the time plus gravity t multiplied by time to the second squared divided by 2. But we don't have the initial velocity of y, so we get it by multiplying sine 61 degrees multiplied by 2.15, and it gives you 1.88 meters per second. And now we substitute. It says that 0 meters plus 1.88 meters per second multiplied by 0.28 seconds plus minus 9.8 meters per second multiplied by 0.28 seconds to the second power divided by 2 gives you 0.142 meters. Now they want to know the speed, but for the speed we need to have the final velocity of y and x. And for the final velocity of y, we need to know the initial velocity plus the gravity multiplied by the time. And here is 1.88 meters per second plus minus 9.8 meters per second squared multiplied by 0.28 seconds. So the final velocity of y, it is equal to 0.864 meters per second. And the final velocity of x, it is equal to the initial velocity of x. So this means that the final velocity of x, it is 1.4 meters per second. And now the formula that said the total speed, it says the square root of the final velocity of y to the second power plus the final velocity of x to the second power. We substitute the values and now we get to the result that it is 1.352 meters per second. The third problem, it is asking the maximum height. The formula says that y max, it is equal to minus initial velocity of y to the second power divided by 2 gravity, which means minus 1.88 meters per second over 2 multiplied by minus 9.8 meters per second squared, and this gives you 0.180 meters. Now the fourth one, it is asking you the distance the cricket will have without the bat. But we have a formula that says that x maximum, it is equal to the initial position of x plus initial velocity of x multiplied by the time, but we don't have the time. So the time, it is given by 2 times the maximum time. It is equal, and the maximum time, it is equal to minus initial velocity of y divided by gravity. And here we have minus 1.88 meters per second over 9.8 meters per second squared. Now the maximum time, it is given by 0.1988 multiplied by 2, and this gives you the total time. Now we have all the values and we can substitute. It is equal to the initial velocity, it is equal to 0 plus 1.4 meters per second multiplied by 0.3836 seconds, and this gives you 0.3989 meters, that we can deduce that it is equal to 400 meters.